Welcome back, designers and engineers. In this video, we will build a complete chain and sprocket setup using top-down assembly approach. We will start with the shaft, then create sprocket, and finally model every link of the chain directly in the assembly so each part fits perfectly. Working this way makes it easy to take reference from one component to another and keep everything aligned as you go. It's not difficult, but it does take a bit of focus and patience. So let's get started. First, we will begin by creating the new component. For that, from create, you can take new component and here name we will give shaft because we'll be creating shaft first as the first component of the top-down assembly. Now the shaft one is created and it is fixed by default and activated. Now let's start creating the component in front plane. Draw a circle of diameter 10, then invoke, extrude, and wall distance, the total distance is 45. Okay, so in our shaft, we are creating a simple shaft and let's give shaft chamfer of length is 1. Okay, so this is our shaft is complete. Now for second component, first activate the main assembly by clicking this radio button. Now from create new component, name let's give sprocket. We are going to create sprocket of the assembly. Now our sprocket one is inserted and we are going to create the sprocket. Sprocket one is also activated. So select the right plane and let's project. Yes. Now this shaft is projected. Now we can take line tool and make it construction line. Draw a center line from origin. Okay. Now change construction line. Then from here, we are drawing the profile for the shaft. So this profile is to revolve. Draw a profile like this. Okay, horizontally, then from there vertically downwards. Now finally connecting to the starting point. Yes, now the profile is complete. Let's give constraint. Make it horizontal. Okay, now select both lines. Then center line and choose symmetry. Likewise here also, let's give symmetrical relation. Okay. Select these two vertex and give horizontal relation. Now we can apply dimension. Before applying, let's draw a horizontal center line from origin. Okay. Now take dimension. We are going to give diameter dimension because we are going to revolve this profile. You can right click and choose diameter. It's 30. Now again select the horizontal line, then the line. Right click and choose diameter dimension. The diameter is 45. Okay. Now here the length is 3. Okay, here also let's give 3. If you have applied equal constraint, then you don't need to give the dimension. It will be applied automatically. And finally here 4. Yes, now the profile is complete. Now let's revolve it. Invoke revolve. Profile is selected by default. Axis, select the horizontal line. Okay. So the base profile for the sprocket is complete. Now we have to give teeth. Select the front plane as sketching plane. Okay. Now invoke circle and draw a circle of diameter 55.6. Yes. Now convert to construction line, then draw a circle of diameter 50. Now you have to draw a center line. Draw a center line from origin, then an angled line. You can press the tab key and type 9. It is 9 degree from vertical line. Yes. Now take center point arc, then change construction line, placing the first center of the arc here on the vertex. Draw an arc. Okay. Now select the arc and the circle and give tangent relation. After giving tangent relation, take center point arc again, then placing the first point here, connecting the first arc, previous arc, draw an arc. Yes. Now we have to give tangent relation between these two arcs. After giving tangent relation, we can remove this small entity. From this entity, now we got the smooth transition. Now let's give radius. Radius of this arc is 7.8. Okay. Now take 3-point arc and here draw an arc like this, touching the circle to the arc. Now make it tangent, circle and the arc. Yes, after giving tangent relation, we can give radius. Radius of the small arc is zero point 0.5. Then let's trim this entity. Okay, we can remove these entities. Now invoke mirror. Select these sketches. Select the sketches, the arcs which we have drawn. Okay, make sure you select all the sketch. Then mirror it to the opposite side. After mirroring, we can extrude it. Invoke extrude and direction to symmetric, total distance. Select the profile and the distance you can give 4. Yes. Now invoke rectangular pattern and make it circular pattern from type in object type features, and from timeline you can select the extrude feature. Axis, select this axis. Yes. And the number of teeth is 20. Okay. Yes. Now we have to remove some material. For that, on right plane, let's draw a profile. Draw a circle of diameter 55.6. Then from here, another circle 45. You can change to construction type. Yes. Now take line tool and from origin, draw a vertical line. Then another anchor line. Then again, one more line. Now let's give the angle between the line. The angle is 1, and from vertical line to this center line, it is 3 degree. Now we can change the line type and take 3-point arc. After taking 3-point arc, starting from the vertex to the end of the circle, draw a tangent arc. Make sure it is tangent arc. Okay. After that, invoke project and project this side. It. Okay. After projecting, from modify, take extend and extend the arc till the projector line. Yes. Now after that, let's give mirror, invoke mirror, select the line. Mirror line is center line. After mirroring, let's draw a center point arc, placing the center in the vertical line. Draw an arc coincident to these two arcs, the mirrored arcs. Make sure it is coincident. The arc is coincident to the mirrored arcs. Now let's give constraint and make the arc constraint fully defined. Yes. Now you can trim these entities. Trim this one. Yes. After trimming dimension from the center of the arc, the height is give 7.1. Okay. Then you can give the radius of this top arc is zero point 0.5. Yeah. After giving dimensions, you can trim this arc. Yes. Now we have to cut this outer profile. For that, we have to get a closed sketch. So from here, we have to draw a line, take line, and from the end of the arc, draw a profile. Draw a profile like this. Yes, make sure both the lines are vertical and coincident to the edge. Then draw a horizontal line because we are going to revolve cut. Okay, bring to isometric view. The shaft we have to hide. Hide the body of shaft, expand the node, and hide the body. Okay, now let's cut it. Invoke revolve. Profile is selected by default. Axis, select the horizontal line. Okay, and operation cut. Yes. So we have got this profile. Yeah. So this is the exact profile which we need, and this shape we have achieved. Okay. Now you can unhide the body. Yes. Let's activate the main assembly, and you can see the sprocket and the shaft. Now let's start creating the link, chain link. For that, let's add the new component. Component name is link outer. Name as link outer. Okay. Now link outer is added and is activated. Now let's create the link. Start sketching on the front plane. Now let's draw the profile. Invoke circle and make it construction line. Then draw a circle of diameter 50. Then take center line. Then draw a center line from origin. Then an angle line. You can press the tab key and type 9. The angle between the vertical center line to the angle is 9 degree. Likewise here also, draw a line and give the angle 9 degree. Okay. Now invoke circle, change construction line, and from this vertex intersection, then draw a circle of diameter 3, then another circle of diameter 4, then again third concentric circle of diameter 6. Yes, after drawing 3 circles, you have to mirror the circles. For mirroring, adjust the dimensions. Now invoke mirror. You can select 3 circles and mirror line, center line. Okay. Next, you have to take 3-point arc and tangent to these 2 circles. Draw an arc. Then take line 2. Draw a line, straight line connecting 2 circles. Now give tangent relation between arc and the circle. Then give dimension. The radius of this arc is 3.5. Okay. Now we have to mirror this. Let's Invoke mirror, select the arc, mirror line, select the horizontal line. Yes. Now we got fully defined profile. Now let's say extrude, invoke extrude, select these two profiles, then the center one. Yes. You have to select these profiles. Total is 5. And extrude to a distance of -1. In operation, make sure it is new body. Okay. Now let's turn on the visibility of the sketch. Invoke extrude, select these two circles, direction symmetric, and measurement half length is -3.5. In operation, new body. Okay. Yes. Now we have to align this first body on top of the second body. So that invoke align and click this center point of the circular face as from and to center point of the cylindrical face. Yes. Now the body is aligned to the top of the cylindrical body. Yes. Now we have to mirror the body. From create, you can select mirror, and in object type body, select the body. Mirror plane, you have to select front plane. Select the front plane as mirror plane. Yes. Okay. So the first link, this is outer link, is complete. Now you can see 4 bodies are created. We have to combine these bodies. Select all these bodies, invoke combine, and yes, combine the body to make a single body. Okay. Now let's activate the main assembly and create the inner link. Invoke new component. Let's give the name as link inner. Okay. Now link inner is created and activated. So let's activate the sketch. Turn on the visibility of sketch if it is not turned on. Extrude and select these two profiles. Then extrude it to a distance of 1. Okay. Make sure operation is new body. Now again invoke extrude, select these two profiles, inner profile and direction symmetric, distances to 0.5, that is half length. You can remove this inner selection. So you get a ring. Operation new body. Just like we did with outer link, we have to align the body to the top of the cylindrical face. So invoke align and select the center of the circular face, then the center of the cylindrical face, and bring it here. Okay. Now let's mirror it. Invoke mirror. In object type bodies, select the body, mirror plane, select the front plane. Okay. Yes. Now let's combine all 4 bodies we have created into a single body. Okay. Yes. Now activate the link outer and turn on the visibility of bodies. Okay. Invoke move. We have to move the outer link to an angle of 18 degree. So rotate it, axis, select the circular edge and rotate it to an angle of 18 degree.
Okay, yes. Now you can see link outer and link inner. Now we have to create the chain. We can activate the link inner. Okay. Turn off the visibility of sketch and activate the main assembly. Now we have to pattern the links so they form chain. So invoke circular pattern. Select these two components and in distribution is full, quantity is 10. Okay. So the chain we have created. Next what we have to do is invoke copy or move object as component and select this component, the outer link, and axis, select the circular edge, and let's rotate it to a degree of -18. After rotating, again invoke move or copy, select the component, move type is translate, to right side move a distance of 7.822. Okay, just like that. Here select the component and let's rotate and move it to the right side. Move or copy, faces components, and select the component, rotate. You can select the circular edges axis and rotate to an angle of 18 degree. 80. Yes. Now let's move it. Again invoke move. Select the component, translate to right side -7.822. Okay. Next invoke rectangular pattern. You can capture the position, object type, select outer and inner components, axis, select the x-axis to a distance of 7.822 into 2. Okay, quantity is 7. Here in distribution spacing, so let's change one more time, 7.822 into 2. Yes, so this is the distance. You can click on OK. After that, you have to move the component and place it to the end of the chain. Invoke move or copy. In direction, you have to change to pick direction. Now you can select multiple components with different direction orientation. Don't miss the components. Select all 7 sections and axis. You have to select the horizon. Select x-axis, distance 7.822 into 12. Okay. After that, we have to rotate the end of the rectangular pattern, this component. Move or copy, rotate it to select the circular edge of the component as angle and the axis rotated to 80 degree. Okay, just like that to the bottom one. Axis, select the circular edge and rotate it to 80 degree. Okay, Now we can see it is okay. Next, let's move the shaft and sprocket, capture the position, rectangular pattern, in object type components and select the shaft and sprocket. Axis, x-axis. Okay, now we have to move it to a distance of 93.9. Quantity is 2. Yes, so we have completed the top-down assembly.
And that wraps up the modeling part. All of the components are aligned and assembled because we use the top down approach, which keeps everything connected from the start. The next step is to apply joints. I will cover that in the next part, but if you already understand how joints work, feel free to try them on your own. So, thank you for watching. For more videos, keep in touch with us. Thank you.